Okay, minus 3. Okay, so we have to take the transpose of this matrix. 2 minus 9 minus 6 0 minus 2 minus 1 3 2. Okay, so that is my adjoint. Now I have to calculate the inverse of this matrix. So let's move to the next page. So A inverse adjoint of A. So what is the determinant? Minus 1. And what is the adjoint? Adjoint is 2 0 minus 1 minus 2 minus 2 minus 3 minus 6 minus 1 2 2. Okay, so my matrix will be minus 2 0 1 9 2 3 6 1 and minus 2. This is my A inverse. Okay, now consider this system of linear equations. What is the linear equations? Just forgot. Okay, so that's my linear equation. X minus 2y plus y plus 2z equals to 1, 2y minus 3z equals to 1, 3x minus 2y plus 4z equals to 3. Okay, so let's write the augmented coefficient matrix, sorry, not augmented coefficient matrix, that is 1 minus 1 2 0 2 minus 3 3 minus 2 4. So it's equals to A. Now the variable matrix X is equals to X Y Z and B is equals to 1 1 3. Okay, so I can write this in matrix form as AX equals to B. So this is P. Now we have already calculated the A inverse. We know that A inverse exists. So let's multiply with A inverse both sides. So A inverse, after multiplying both, we will get A inverse B. So that it will be minus 2 0 1 9 2 3 6 1 minus 2 xy, sorry, not xy, 1 1 3. Okay, so let's multiply. Minus 2 plus 3, that is 1, 9 plus 2 11 plus 3. I think something is wrong. A inverse. What's wrong in this problem? I'm getting all the values right. 9 2 11 3 14. I guess something is wrong in the question. The values are not getting right. Let's move to another question. This question is wrong. Okay, so next question. solve 5x minus y plus 4z equals to 5, 2x plus 3y plus 5z is equals to 2, 5x minus 2y plus 6z is equals to minus 1. So that's my matrix. Let's take A as the coefficient matrix. 5 minus 1, 4, 2, 3, 5, 5, minus 2, 6. What is my x? X, y, z. And what is B? 5, 2, minus 1. Okay. So let's calculate the determinant of A to get the A inverse. 5, 18 plus 10 minus plus 1, 12 minus 25 plus 4 minus 4 minus 15. So by calculating this, we will get 140 minus 13 minus 76. That's nothing but 51. So not equals to 0. Okay. So A inverse exists. Now I have to find the adjoint of A. Okay. So what will be the adjoint? Adjoint will consist all the cofactors A11, A12, A13, A21, A22, A23, A31, A32, A33, and then I have to take the transpose of it. Okay. So what is the cofactor number 1? Suppose remove this 5, you will get 18 minus say A11. A11 is nothing but determinant of 3, 5, minus 2 and 6. That is 18 plus 10. Okay. (18 minus) that is 28. 812. A12 is we have to take a minus, that is 2, 5, 5, 6. So that is minus 12 minus 25. So that will be 13. 13. Then what will be A13? 2, 3, 5 minus 2. That is minus 4 minus 15. That is minus 19. A21 is minus of minus 1, 4, minus 2, 6. That is 1 minus 6 plus 8. That is minus 2. What is A22? 5, 4, 5, 6. 30 minus 20, that is 10. Then A23, take the minus, determinant of 5 minus 1, 5 minus 2, that is minus of minus 10 plus 5, that is 5. What is A31? A31 will be minus 5 minus 12, that is minus 17. A232 will be 25 minus 8, that is minus 17 again. And what is A33? A33 will be 15 plus 2, 17. Okay, then you have just find the A inverse and multiply with A2, the B, you will get your answer. Next, move to the next question. Question number 6. Solve the following problem using matrix method. Solve the following equations. 5x plus 3y plus z equals to 16, 2x plus y equals to 19, x plus 2y plus 4z equals to 25. Okay, so we have to solve this equation. Now write it in a matrix form. My A matrix is 5 3 1 2 1 3 1 2 4. What is my B? 16 19 25. What is my X? X is X, Y and Z. Okay, now calculate the determinant of the matrix. Determinant will be 5 4 minus 6 minus 3 8 minus 3 plus 1 4 minus 1. So I will get minus 2 minus 10 minus 15, 5 minus 15 plus 3, that is minus 22. So that's my determinant. Okay, so is non-zero, it means A inverse exists. Now from this you can write that Ax is equals to B, and clearly multiply A with X, you will get B, and that is my this system of equation. Now as A inverse exists, you can multiply A inverse in both sides, then you will get A inverse B. Now you have to find this A inverse. Okay, so for this you have to calculate the adjoint of A first. So what is the adjoint of A? You have to take the big matrix and you have to take the transpose of it, which will consist the cofactors. So what will be the first cofactor? First cofactor will be 1 3 2 4 minus, what is the second? Second one is 2 3 1 4. Third one is 2 1 1 2. Fourth one is minus 3 1 2 4 plus, not need to write plus, 5 1 1 4 minus 5 3 1 2 3 1 1 3 minus 5 1 2 3. Last one is 5 3 2 1. You have to take transpose of it. Then my required matrix will be 4 minus 6 is minus 2, 8 minus 3 minus 5, that will be 2, 4 minus 1 is 3, minus 10, then 20 minus 1 is 19, it will be minus 7, 8, minus 13, minus 1, then the transpose, then it is, after taking transpose you get minus 2, minus 5, 3, minus 10, 19, minus 7, 8, minus 13 and minus 1. Okay, so that is my adjoint FA. Now what is the A inverse? A inverse is nothing but A inverse is nothing but 1 by determinant of A into adjoint of A. So we will get minus 1 by 22, and what is my adjoint? My adjoint is minus 2, minus 10, 8, minus 5, 19, minus 13, 3, minus 1. Not need to multiply, don't this minus 1 by 22 with the matrix. We will calculate the multiplication with B first, then we will multiply it. Okay, that will be easier. Okay, so let's X equals to A inverse B. Now what is A inverse? 1 by 22 minus 2, minus 10, 8, minus 5, 19, minus 13, 3, minus 7, minus 1. What is my B? My B matrix is 16, 19 and 25. Now let's calculate 1 by 22, multiply them, minus 32 minus 190 plus 200, that will give you a minus 22, minus 80 plus it is plus 361 minus 325 will get you minus 44, then plus 48 minus 133 minus 25 will give you minus 110. So my answer will be 1, 2 and 5. So this is my solution. What is my solution? My solution is x equals to 1, y equals to 2 and z equals to 5. So that's my solution. Let's move to another question. I'm listing some properties of adjoint, that's very important for you. Let me write. Please take note down of it. So here are some properties of adjoint of a matrix. Okay, so what is the first property? Right, the first property is if A is a square matrix of order 3, then A into adjoint of A is equals to determinant of A into I cube. I cube means I3, sorry, not I cube. I3, what is the 3 cross 3 identity matrix? And this is also equals to adjoint of A into A. Okay, you will get MCQ questions which you have to solve using these properties. Okay, second property, if A is a square matrix of order n, the generalization of the last property, A adjoint A is equals to determinant of A I n adjoint of A into A. Then the third property is that A B inverse is equals to B inverse A inverse. Now the fourth property is if A is invertible, then the A transpose is also invertible, and A transpose inverse is equals to A inverse transpose number 5. Determinant of if A is a invertible is an invertible matrix of order n, then the determinant of adjoint of A is equals to determinant of A to the power n minus 1. Now the sixth property is, that's the last property. So these properties are very, very important for your exam. You will get MCQ questions, then you have to solve them using this properties. Okay, these are 5 properties. Note them down. Note it down. Then we will solve some questions on these properties. So let's move to the question. It is asked that if A is given 1 minus 1 2 3 1 minus 2 1 0 3, find determinant of adjoint of A without computing the adjoint of A. So without computing any matrix, we will get its determinant using the above written properties. So first of all, you have to find the determinant of A. Okay, so what will be the determinant of A? I will expand it using this last row as it contains a 0. 1 into 2 minus 2 plus 3, 1 plus 3, so that is 12. That's non-zero, hence A inverse exists. A is non-singular. Now as this matrix is 3 cross 3 matrix, so what is the formula of determinant of adjoint of A? Determinant of adjoint of A is equals to A determinant of A to the power n minus 1. N is the order of the matrix. Now here n is 3, so that will be 3 minus 1, so determinant of A square, that is 144. So I didn't compute adjoint of A, but I got the determinant of it. How? With this fifth property. Okay. Let's move to next question. It is given that A is a 3 cross 3 invertible matrix. Three cross 3 invertible matrix, and determinant of A inverse equals to A to the power k. Find k. Okay, so answer, as A is invertible, so determinant is non-zero. Okay, so A inverse is equals to identity, we know that. Then determinant of A inverse is equals to the identity, determinant of A into determinant of A inverse equals to 1. Determinant of A inverse is 1 by determinant of A. We use this property, determinant of AB is equals to determinant of A into determinant of B. Okay, so from this I can write this as determinant of A inverse is equals to determinant of A to the power minus 1, so k is equals to minus 1. Okay, this question is from the NCERT. Let's move to the another question from NCERT exemplar. It is asked that if A is a 3 cross 3 invertible matrix, then show that for any scalar k, k is invertible, ka is invertible, and Ka whole inverse is equals to 1 by K A inverse. So let's calculate. Say as A is invertible, what does it mean? Determinant is non-zero. Okay, so we know this property of determinant, that if determinant of Ka is nothing but k to the power n into determinant of A, if A is a n cross n square matrix. So this is the property of determinant we used here. Okay, so that is k cube A, which is also non-zero, as it is given that okay, in question is also mentioned that k is non-zero. So as k is non-zero, determinant of A is non-zero. Simply determinant of A is non-zero, so k cube A determinant is also non-zero. Okay, now we have to find the identity that was given here. Okay, so let's multiply Ka with 1 by K A inverse. We will get K into K, the multiplication of scalar, then I will get the multiplication of my matrices, that is 1 into identity matrix, identity of matrix of order 3, so I3. So it is clear that the inverse of this matrix Ka is nothing but 1 by K A inverse. Okay, that's also for my inside NCERT exemplar. We will discuss next question.
না আমি আবার একটু পড়াতে চলে যাব
If x, y, z all are non-zero, A equals to x 0 0 0 y 0, then find the A inverse. Okay, so let's find the determinant at first. Determinant is, we know that if a matrix is a scalar matrix or upper triangular matrix or diagonal matrix or lower triangular matrix, the determinant is the product of all its diagonal elements. So what are the diagonal elements? That are x, y and z. So this is my determinant. As all of 3 is non-zero, so our determinant is also non-zero. It means A inverse exists. So we have to find the adjoint of A. Okay, so what is the first cofactor? If you take this x out, the first cofactor is yz minus 0, so that's 0. From this 0 0 xz, then হচ্ছে 0 0 xy. Okay, so this is my adjoint. Now what is A inverse? adjoint of A. So if you divide it, you will get 1 by x 0 0. Okay. Next, we have to find the inverse of this matrix. Cos alpha, sin alpha, sin alpha minus cos alpha, cos alpha. Okay. So A inverse. One minus cos square alpha minus 1. Okay. A inverse exists at my determinant is non-zero. Now adjoint of A. Okay. What is my adjoint? My adjoint will be, first take the cofactor, it will get minus cos square alpha minus sin square alpha. My second cofactor will be 0. My third cofactor will be also 0. My third cofactor is also 0. Fourth cofactor will also, let's see what is my middle, minus cos alpha plus sin alpha minus sin alpha minus sin alpha cos alpha. So this is my adjoint transpose. We'll get mine. Sin alpha cos alpha. Now A inverse So next question is, find x such that ax squared xa minus 2y hence find a inverse. Okay, three into 3 is 9, minus 4 is 8, that is 1, minus 6 plus 4, that is minus 2, 12 minus 8 is 4, minus 8 plus 4, that is minus 4. So that is my a square. Now three x minus 2 minus 2x 4x minus 2x minus 2x. Now it is equals to the a square. So what is the a square? That is 1 minus 2, 4 minus 4. Okay, so if you compare these both sides, you will get 4x equals to 4, that will give x equals to 1. Okay, so now from this identity I got that a square equals to a minus 2i. Okay, now let's calculate the determinant of a. Okay, determinant is minus 6 plus 8, that is equals to 2, that is non-zero. It means a inverse exists. Okay, so let's multiply it with a inverse. We will get a, the identity, minus 2a inverse. So okay, so that's my a inverse. That's quite an important question. Okay, so next question, similar type. A equals to minus 1, then we have to show that it satisfies the equation It satisfies the equation x square minus 3x minus 7 is equals to 0, and hence we have to find A inverse. Okay, 25 minus 3 is 22, 15 minus 6 is 19, minus 5 plus 2 minus 3 minus 3 plus 4 is 1. Okay, so that's my A square. Then we have to show that the matrix satisfies this polynomial, this equation. So put this matrix here. So suppose this is fx. Now put A here. So we will get A square minus 3A minus 7I. Okay, so this is my minus 3A will be 15, 9 minus 3 minus 6, 7007, 0, 3A, my A is 9, so that will be again 0. I think something 15 minus 6, sorry, this will be 15 minus 6 will be 9. Yes, okay, that will be 9. So that is 0. That will be 0. So it is clear that A satisfies the equation. Minus 7, that is non-zero. Okay, A inverse exists. Okay, now adjoint of A. So not needed to find the adjoint, as the matrix satisfies this equation. Minus 7I. A inverse A inverse. What is A? A is 5, 3 minus 1 minus 2 minus 15, sorry, that is 3, by 7 minus 1 by 7 minus 5 by 7. So that's the A inverse. Okay, let's move to next question. Let's move to next question. Find A inverse if A equals to 0 1 1 1 0 1 1 1 0. Also okay, so first find the A inverse, find the determinant. Inverse exists. Okay, so that's my adjoint of A. So my A inverse is equals to 1 by determinant of A into adjoint of A, half minus 1 1 1 1 minus 1 1 1 1 minus 1. Okay, so that is my A inverse. Now I have to compare it with A square minus 3i by 2. Okay, so let's see what is my A square. Zero 1 1, that will be 2, 0 0 0 1 0 0, that is 1 1 0 1 1 0 0 1 1 0, that is 2. That is my A square. Now A square minus 3y is minus 1 1 1 1 1, sorry, minus 1 1 1 1 minus 1, and if you take the half of it, it is equals to A inverse. Okay, So proved. Let's move to the last question of today. We have to solve a square equals to, a equals to 423 111 31 minus 2 4x plus 2y plus 3z equals to 2, x plus y plus z is equals to 1, 3x plus y minus 2z is equals to 5. Okay, now I have to solve it. Write B matrix 2 1 5, my X matrix x y z. Okay, now first calculate the determinant. I will get 4 minus 2 minus 1 minus 2 calculating minus 8, so that's non-zero. It means A inverse exists. So what is my A inverse? My A inverse will be 1 by determinant of A adjoint of A. Now let's calculate the adjoint of A. I am directly writing the value. That's my A inverse. Now I have to find the X. So from this I will get, after multiplying, 6 minus 7 plus 5, 6 plus 5 11 minus 7 will give you 4, minus 10 plus 17 plus 7 plus 5 it will give you 12. 4 minus 2 is 2, minus 10 will give you minus 8. So from this I am getting the value half 3 by 2 and -1. This is my solution. Okay, so that is it for today.